You know, we're surrounded by these invisible dangers every single day. We're talking about toxic metals that could be in our water, our food, even in the soil around us, but we can't see them. So how do scientists actually find these microscopic threats to keep us all safe? Well, let's dive in and find out.
Okay, so let me ask you something. What if the biggest dangers out there aren't the ones you can see? We're talking about toxic metal ions, and believe me, they can show up in the most unexpected places.
For instance, let's take lead. It can slowly leach out from old paint or aging water pipes. And even in the tiniest amounts, it's incredibly dangerous, especially for kids, where it can cause some really serious developmental issues.
And then you've got mercury. You might find it building up in contaminated fish. As it moves up the food chain, the concentration gets higher, and for us, it can directly attack and damage the nervous system.
And we can't forget about arsenic. It's often found hiding in contaminated groundwater. And if you're exposed to it over a long time, it can lead to skin lesions and a much higher risk of cancer. These are major threats. And the crazy part is, they're all completely invisible.
So, that brings us to the mission, right? How in the world do scientists actually find these poisons when we're talking about microscopic amounts? It's a huge challenge, and it requires some absolutely incredible precision.
And the scale of this problem is just immense. I mean, we're trying to detect concentrations down to parts per billion, or even parts per trillion. To give you an idea, that's literally like trying to find one single drop of ink in an entire Olympic-sized swimming pool. To do that, you need some seriously advanced tools.
So let's start with our first high-tech tool. It's called Atomic Absorption Spectroscopy, or AAS for short. The best way to think about this thing is like a super-specific lock-and-key system. It's designed to find one and only one specific type of metal at a time. Now, the science behind it is just fascinating. See, every single metal element has its own unique fingerprint, a very specific wavelength of light that it just loves to absorb. AAS shines that exact wavelength of light through a sample. So the more light that gets soaked up, well, the more of that metal you have. It's so elegant and super effective.
So how does this work in the lab? Well, first you take a sample, maybe water or soil, and you use acid to free up all the metal ions. Second, that sample gets zapped with intense heat in a flame or a furnace, creating this little cloud of individual atoms. Third, that special beam of light we talked about gets passed right through the cloud. And finally, a detector on the other side measures exactly how much light made it through, and that tells you the concentration.
And AAS is really versatile. Depending on what metal they're looking for, scientists use different methods. A standard flame works great for elements like zinc and copper, but for the really nasty stuff like lead or arsenic, they need something more sensitive, like a graphite furnace. There's even a special cold vapor technique that's used just for detecting mercury. It's all about picking the right key for the right lock.
Okay, so let's move on to our second tool. If AAS is a precision lock and key, then our next one, inductively coupled plasma mass spectrometry, or ICP-MS, well, this thing is the ultimate sorting machine. It doesn't just look for one element, it scans for dozens of them all at once. The secret ingredient here is plasma. The instrument uses argon gas and a whole lot of energy to create a state of matter that is unbelievably hot. When the sample hits this plasma, its atoms are instantly stripped of their electrons, which turns them into charged particles that we call ions.
And when I say unbelievably hot, I'm not kidding. The plasma inside an ICP-MS instrument gets up to 10,000 Kelvin. To put that in perspective for you, that is nearly twice as hot as the surface of the sun. Wow! That incredible energy guarantees that every single element in the sample gets ionized and ready for analysis.
So here's the whole process. First, the sample gets turned into a fine mist. Then, that mist is shot into that crazy hot plasma, creating a stream of ions. And this is where the sorting begins. A powerful magnetic field separates the ions based on their weight. Lighter ions get bent more sharply, while the heavier ones take a wider turn. And finally, a detector at the end literally counts each type of ion, giving you this amazing, full profile of almost every element in the sample, all at the same time.
So you can see why this is such a game changer. It can scan for tons of elements at once, which makes it super fast and comprehensive. It is extraordinarily sensitive. It can often detect even lower concentrations than AAS can, and it's incredibly versatile. You can use it to analyze everything from drinking water to soil to human tissue.
So, how do you choose which one to use? Well, think of it this way. ASS is your go-to when you know exactly what you're looking for. Let's say you just need to check the lead level in a water sample. It's precise,
It's reliable and it's cost-effective. But if you need a full screen for a whole range of potential bad guys, ICP-MS is the powerhouse that gives you the complete picture, even though it is a bit more complex and expensive.
Okay, so we've got these incredible tools, right? But what does it all really mean for us? This isn't just about numbers on a lab report. This is about turning that science into real-world public safety.
And this really gets to the heart of it. Dr. Yoganathan puts it perfectly. Assessing metal ion distribution and concentration is key to managing human and animal health risks. In other words, by being able to accurately measure these invisible metals, we can directly manage the very real risks they pose to all of us.
Believe it or not, this science is working for you every single day. It's the reason we can be sure our tap water is safe to drink. It's how safety limits are set for things like mercury in the fish we eat. It's used to monitor pollution from industrial sites and to figure out the best way to clean it up. From forensics labs to pharmaceutical companies, this analysis is a cornerstone of our modern safety net.
You know, our ability to see the invisible is only getting better and better. And that leaves us with one last big question. As these tools become even more powerful, what new secrets are they going to reveal about the health of our planet and about our own health? It's a question scientists are working on every single day. Thanks for watching.